So in this video, I'm going to look a little bit more at an example, an engineering application for indices and what we might come across. Now logs are integrated in here as well, and generally wherever you have indices you're going to have a bit of logs in there too. So we look at a formula that describes a particular system. We see here we've got delta equaling the natural log of e to the power of minus z omega t1 all over e to the minus z omega t2. Okay, now that looks like a pretty complex formula to us, but there's not too much going on. We've a lot of Greek letters, but we shouldn't let that deter us. Basic thing we're looking at is here is that we've got a base, the same base for each, even though it's e, the constant e, and it's being raised to, a variable, ultimately a function here of z, omega and t. But once we have the same base, we can apply still the rules of indices. So if we just look at the rule, that's common. Just get a different color pen here. So the main rule we're applying here is that if we have a base to a power and we have the same base to another power, that will equal the same base to the difference of the powers. Okay, so that's the rule we're applying. And ultimately, E can be represented as A, and this whole part here can be represented as your power N, or indeed, fully take you out, M. So we can continue on with that. We can, just skip ahead there, apologies. We can look at delta equals the natural log of E, it's a bracket, E, then we have the difference between minus z omega t minus z omega t2. It's t1 and that's t2. And that's what you have there. Then I can take that a step further. Again, we've delta equaling the natural log of E. Ultimately what we're left with will be minus z omega t. The minus and minus give you plus the omega t. That's t2 and that's t1. Now we know from our law of logs that the ln is going to cancel out our e. So then we get delta equaling to minus z omega t1 plus z omega t2. And again, we can make that a little bit nicer. We factorize out our z and our omega, and we can be left with t2 minus t1. All I did there was, when I take that out, I was going to be left with minus t plus t2. We can just rearrange that to something a little bit nicer. So you see there a little bit of a law of logs there, just that the natural log will cancel out our e. But all we're doing is applying a rule of indices. Now this is an engineering application where we're going to get a particular formula like this. We got to simplify it, but we can't be too put off by what's going on here. Just see it as a rule, apply the rule, we can simplify it right down.